Introduction to functions. Our topic is introduction to functions. What is a function? A function is a rule that assigns exactly one output value for each input value. Formal definition: a function f from a set A to a set B is a relation such that for every x belong to A, there exists a unique y belong to B such that f functions A tends to B, y equal to f of x. Examples: f of x equal to x square, f of x equal to 1 upon x, f of x equal to sine x. These are examples of functions. Not a function if one input gives multiple outputs. Examples: the relation x square plus y square equal to 1. A circle is not a function because you can see here, if we put any values then we can get multiple outputs. So this is not a functions. Physical meaning of functions. In physics and engineering, functions model real-world relationships. Examples: distance, time, ht equal to f of t. Distance covered at constant speed. Hooke's law: f of x equal to minus kx falls in a spring. Ohm's law: Vi equal to IR. Voltage as a sign of functions of current. Real world meaning: one quantity depends on another. Graphs of basic functions. Linear functions: f of x equal to mx plus c. Straight line: slope equal to m. Intercept equal to c. You know, linear function is defining. Quadratic functions: f of x equal to ax square plus bx plus c. This is a quadratic functions. Parabola opens up if a greater than 0, down if a less than 0. Cubic functions: f of x equal to x cube. H shaped, curved, symmetric about origin. Absolute value functions: f of x equal to, you can see here, the absolute function is given. V-shaped graph, sharp corner at x equal to 0. Square root functions: f of x equal to radical x, only defined for x greater than equal to 0. Gauss slowly starts at 0, 0. Reciprocal functions: f of x equal to 1 upon x, hyperbola, undefined at x equal to 0, exponential functions: f of x equal to a x. Now you can see here a power x, easy, 2 power x, comma, e power x. Rapid growth horizontal asymptote at y equal to 0. Logarithmic functions f of x equal to log x defined for x greater than 0. Slow growth vertical asymptote at y x equal to 0. Trigonometric functions f of x equal to sin x, cos x, periodic oscillating curves. Applications waves, signals, pendulums. Domain and range. Domain all possible input values. Range all possible output values. Functions x square, domain means real number, range 0 to infinity, infinite number may be. If function is given radical x, domain start 0, comma infinity, and also same process is given. Now you can see here 1 upon x same real number, and we can get real numbers also. If put the 0, then we can 0, same process. Composition and transformation. Vertical shift f of x plus c. Horizontal shift f x minus c. Reflection minus f of x, comma f minus x. Scaling a f of x, comma f a x. Summary. A function is a rule linking input and output. Physically, function describe dependent relationships. Graph visualize behavior, trends, and properties. Understanding graph helps interpret real-world data. Now you solve these questions. This is for your practice questions. Plot the graph of f of x equal to x square minus 4. Second, identify domain and range of f of x equal to radical 3 minus x. Third point, sketch the functions f of x equal to, you can see here, modulus sign x minus 2. Now you solve these questions on your paper and try. You can get any values x. Starting value may be minus values and maybe plus values. And put the values of x, then we get y. And plot the graph from these questions, x-axis and y-axis in paper. Okay.